Well, my dear participants, today I am going to talk about data creation and import export with R. So, I have already opened my file in R Markdown and now I will create the result from the commands. Like here, say for example, we have created a vector and we want to run this. This is a numeric vector. So, control plus enter, we are getting the result. To print this result, we have to use make of print, otherwise that is equivalent to just type the object and press enter. So, it is equivalent to print. Note that R commands are written in a chunk which begins with 3 backticks and end with backticks. So, these are the 3 backticks and end with 3 backticks. This specifies the R chunk in the language. All the R commands are to be written inside this chunk, and here this stands for this hash mark. We have created a section, and then if double hash mark, this is the heading of subsection. So, in subsection we are going to talk about arithmetic operators on vector. There are 5 basic operators in R, namely they are plus, minus, then for multiplication it is star, for division it is slash, and for exponentiation it is hat, which are meant for addition, negation, multiplication and exponentiation respectively. Besides these basic operators, a large number of functions are also available for arithmetic computations. Let us create a new chunk. So, this is the new chunk, and here R stands for it is interfacing with R, and here this is OP vector, this is the leveling of this chunk. Suppose we have already created x, now we want sum of x. So, we have to type sum x and control plus enter. So, we are getting summation of x. Then if you want sum of x square, then we have to put it works on the whole vector. So, summation of x square. Then suppose we want to compute square root of the vector. So, it works for the whole square root. Suppose we want third root. So, what we have to do, control plus 1 in this source window and control plus 2 in this command window. So, here x raised power say 1 by 3. So, it will compute third vector x raised power 1 by 3, and you can have any like x raised power 0.5. So, it will give the fifth root. So, you can have any power. Now, I am going to talk about an arithmetic operation, and that is logarithm of x, log of x. Actually, control 1, we will go to this window, log of x. It is Neperian based log values of the whole vector. So, to get Neperian based log values, we have to type log of x and we are getting the result. These are the log values on Neperian base. Suppose we want log values with base 10, then we have to give additional argument base is equal to 10. So, log of x with base is equal to 10. So, these are the outputs. Similarly, log with base is equal to 2. So, we are getting log with base is equal to 2. And if we want inverse of x, then it is 1 by x. Then x raised power minus 1, it is this. And sine of x. So, these are the sine values in radian. If we want cos values of x, so cos of x, we can get summary statistics also of the data vector x. So, that is mean of x. So, mean is 1.5. Suppose we want to compute median, we have to go to control 2 and here type median of x. Median of x and get median. Suppose I want to add this command, so control plus 1, I am going there. After mean, we can type median of x and we will get median. So, control, and we can run this by using this command, control plus enter. Then suppose we want variance of x. So, variance is defined as, actually the variance measure was introduced by Sir Ronald Fisher, whereas SD measure, SD is another measure which was introduced by a great statistician who first gave central limit theorem. He is De Moivre. So, De Moivre gave the concept of normal distribution as well as he introduced the measure SD. So, here variance of x and then SD of x. I have already talked about SD. So, SD you can compute by making use of, so how we define SD? We define SD as square root of variance. So, control 2 SQRT of var of x. So, here we can get the same result which we are getting on the function SD of x. So, you can verify this these are equivalent operations. And then control 1, I am going to talk about, suppose we want to compute CV. CV stands for coefficient of variation. We need to define a function for it because it is not available in the base R. So, to define a function, first we have to name the function, that is CV, is equal to, then keyword function and its argument is x, then expression. Expression is, see how we define coefficient of variation, it is SD divided by mean into 100. So, we have given expression of CV. So, we can run this and we can get the result. So, CV has been defined. Now, if we want to save this function in our working directory, so what we have to do? We have to use dump function of R. So, dump and the name of the function is CV. So, we have to type in double quotes CV and file cv.txt. So, this will be saved, dump and save. And if we want to call it, the function is source. So, once you have saved this, you have dumped this, you have to just use source, so that there is no need of again defining the function. You can just source. So after source, it will be made available at your disposal. Now we can directly call CV function, CV, and CV is 35 point. Suppose we want to check this, whether this is really CV or not. So what we have to do? It is SD of x divided by mean of x and multiplied with 100. So it is the same result we are getting. 35 point. So this is equivalent to calling CV function. But suppose some data is available with us and we want to call this. So how we will call this? Say for example, there is a package data sets in R, and to look into the data sets, we have to type data and with the bracket. So it will open a window. So this window is there and it has many databases available like BOD, air passengers. So all these data are available with the data sets package. Besides that, there are a large number of data sets which are available with the packages, with the special package, contributed packages. So these are the data sets which are available with the base R, but every package has its own data sets. Now here I would like to search for a data set trees data set, trees. See the diameter, height, here diameter, height, and I am closing this now. Suppose you want to get the help about the data trees. So you have to type help and object is trees, TREES, trees. So here this data is available with the package data sets which is in base R, and the heading is diameter, height, volume of black cherry trees. The description of the data, here the data has been described. It has volume of the tree, black, it has, this data set provides measurements on the diameter, height and volume of timber in 31 felled black cherry trees. Note that the diameter in inches is erroneously labeled as girth in the data. It is measured at 4 feet 6 inches above the ground. Actually, this is known as DBH also, diameter at breast height. If a person stands in the front of a tree and he measures the diameter of the tree in front of his breast, then that is known as DBH, and DBH is a very good predictor of the volume. So here it is DBH actually. And see some other features of the data, like this is a data frame in which girth and then height and volume of tree, all these things are there. Suppose we want to print the data, so just type trees. So it is the trees. And suppose we want to see the names, the column names. So there is a function names of x, trees. names of trees. So here it gives column names, girth, height and volume. Suppose we want to look into the header part of the data. So the function is head trees. So this is the header part. Suppose we want to look into the data from the bottom. So the function is tail trees. So this is from the bottom. So this way, and suppose we want to use this CV function on girth. So how you will do that? You just call CV and you write x is equal to, because x is the volume, x is the argument of the function. So x is equal to trees, and we have to select a column of girth from there. So we use dollar operator to extract a column of data frame. So here CV girth. So this has computed the CV of the girth. Similarly, suppose we want CV of height. So what we have to do? We have to just change here CV of height and we will get the result. Similarly, same function will work for volume also. So CV of volume, we can make use of dollar operator, and we can make use of the function CV. Similarly, suppose you want to define a function for standard error of mean. So I am writing comments here inside this. These are the comments in R. So define function for standard error of mean. So it is nothing but, actually we have to name the function SEM, standard error of mean. Then we are using, this is either we can use equal to or less than. This is the combination of two characters, and this is known as assignment operator in R. SEM is equal to means we are using two, normal less than and dash. So here the keyword function and then argument x, and then I am going to define the function of SEM, and that is nothing but square root of SD, it is SD of x divided by square root of length of x. Length I have already defined. Say for example, control 2, length of x, LENGTH, length of x, here length of x, length is 10. So it counts the number of number of arguments in x, and it is giving the result, and that is length of x. Length of x is 10. And suppose we are simulating a data, say x1, say we are simulating from normal distribution, R norm, suppose 100 observations, and say So we have simulated 100 observations and we have a data, say for example x1. This is the data simulated 100 observations, but we do not know what is the length of the data. So we have to use the function length of x1 and it will be 100. So this way we can know about these things. So this is the length function. Now I am going to use here control plus 1 to come to this window, sqrt and then length of x. So it is nothing but this is the definition of standard error of mean control. So it has been defined. Now we can dump this by using the function dump and double quotes. We write the name of the function, that is SEM, and then we are going to write the file in which it will be saved. So file is sem.txt. I want to keep it as text file. So normally what we do, we write the name with the extension txt so that it is very easy to remember. And then if we want to source this, source, source, and then we have to give the file name in double quotes, and that is sem.txt. So if you run this, this is the, and to save all these changes in the document, we have to use control plus S. So suppose we want to use this, function. So here it will be SEM of x. It is a standard error of mean of x. And then suppose we want SEM of standard error of mean of trees girth, trees, and then dollar, then girth, girth. So it will extract the column of girth from data object trees and it will compute SEM. And a better way is that we can write SEM x is equal to, because x is the argument, and trees dollar girth. Now it will be same, it will give the same result. So this way we can define a new function and we can call that function for in between. It is just like your function which are compiled in C++. It is just defined and it just works. So it is a very powerful aspect of R. You can define your function and you can do computation. Now I would like to talk about recycling rule. The basic rule is that a smaller vector recycles up to the length of the larger vector. Let us see some commands in the following chunk. Say for example, this x is equal to C 5 4 3 1 4. This vector we have created. The length of this vector is, we can compute, it is 5. Now recycle rule tells that if you get x plus 1, so here x is a larger vector, it has 5 elements, whereas 1 is the smaller vector and that is length 1. So 1 will recycle up to the length of the x, the larger vector, and then it will add. So see the result, see. Here this is x plus 1 whereas x is 5. So, it is 5 plus 1, 6, and then we can just run that. See, x is 5, 4, 3, 1, 4. So, x plus 1 is 5 plus 1, that is 6, then 4 plus 1, that is 5, then 4 plus, then 3 plus 1, 4, and then 1 plus 1, 2, and then 4 plus 1, 5. So, this way, this is the recycling rule. This is very important. Even it works in matrices also, not only in vector. See here, 2 raised 2 into x. Here x is of length 5, whereas 2 is single. So, we are multiplying 2 into x. So, here 2 will recycle 5 times and then it will multiply individually with each component of x. Okay. Now, we can do an operation making use of recycling rule. We are computing x plus 1 and then we are computing logarithm. So, it is log of x plus 1. Here 1 recycles up to the length of x and then it adds, and after that we are computing log. Similarly, sine of 2 into x. So, it works on the whole vector. It works on the whole vector. These are the sine values of 2 into x, twice of x. So, this is the recycling rule. Here naming, we want to talk about naming objects in R. Some examples of valid and invalid names are given below. Number 1, A1. A1 is a valid name. 1A is not a valid name as it starts with numeric, whereas $A is not a valid name as it starts from a special character. A dollar is also not a valid name because it contains character. A12 underscore 5, it is a valid name. Atma Ram is a valid name because it has not been fractured, whereas Atma Ram, if you are giving fractured way, it is not a valid name. It is not a valid name, is not valid as fractured names are not allowed. Atma Ram is equal to 5 is a valid assignment. Atma Ram 5 is not a valid assignment. It is not a valid assignment. So, these are the some of the naming conventions of object in R. Now, say for example, control 2, Atmaram. So, Atma Ram is assigned a value 5. So, if we want to print Atma Ram, use cursor key, its value is 5. But if we type Atma Ram is equal to 5, then it is error, unexpected symbol in Atma Ram. So, it will show you error. So, don't keep fractured names. See, Atma underscore Ram is equal to 5 is a valid name. You can type so this is a valid name. So, underscore is also allowed, dot is also allowed. Atma dot Ram is equal to 5. So here dot is also allowed. So you can use in between dot also. So this is the function. This is the valid names. Now we are stopping at this stage, and we will continue in the next lecture. And in the next lecture we shall begin with seek and rip commands. So these are the functions seek and rip, which we will discuss in the next lecture.